Hello everyone, welcome to the third video on shell coding on ARM Linux 32-bit course presented on YouTube. So in this video we are going to talk about the different profiles implemented in ARM processor, ARM architecture. Talking about the history first, ARM or Advanced RISC machine was created by Sophie Wilson and Steve Ferber in Acorn Computer Private Limited. So if you want to know more about ARM, you can just look into the Wikipedia page. As of 2022, about 200 billion devices are getting powered from an ARM processor. So if you are thinking that all of these 200 billion devices run on a same type of ARM processor, then you are wrong. There are several profiles by which the usages of ARM processor are differentiated. So what are all these profiles? So there are three profiles: the profile A, profile ARM, and profile M. Talking about the profile A, here A stands for application. If you have ever tried to just search about the processor used in your Android or iOS devices, you may come to an end result like Cortex A53 processor, Cortex A32, Cortex A72. So here the prefix Cortex A signifies the profile of ARM processor used in your device. The alphabet A signifies that the processor used in your device is an application profile of ARM processor. So what does profile A provides? So it supports a virtual memory system architecture model based on a memory management unit, which helps us to translate the physical memory addresses to that of virtual memory addresses and vice versa, which generally an operating system requires. So profile A does it very well. Talking about the next profile, the profile R. Here R stands for real time. These types of processor are just meant to do some dumb processing. If you have ever wondered to just search about the processors used in X-ray machines, EKG, ECG machines, and the braking systems in smart vehicles, then those tasks are just a dumb task which requires a little amount of processing. So the Cortex R profile of ARM processor does it very well. So these types of processors are used in those tasks which doesn't require high level of processing power and many things like that. Talking about the next profile, profile M, here M stands for microarchitecture. If you have ever tried to just know about the processor in the Arduino board or any kind of microcontroller, then you might come to an end result after searching about that. Those devices use Cortex M32, Cortex M59 and any processor starting with a prefix of Cortex M. Here also M signifies the profile of ARM processor used in that device. So what does profile M provides? It supports a protected memory system architecture model based on a memory management unit. It is same like profile A processors, but the processing power provided is way more lesser than the profile A ARM processors. That's why these kinds of processors are used in microcontrollers, which requires a little bit of processing power, like controlling the Wi-Fi, controlling the Bluetooth, controlling the radio frequency, running a small amount of terminal applications, which requires only a little amount of processing powers. So these types of profile of processor does it very well. So what profile we are going to learn in this course? We are entirely focusing on the profile A because the instruction sets in the profile A ARM processor is a superset of all the instruction sets in the profile R and profile M. So learning about the profile A instruction set will help you to learn about profile R and profile M as well. There are also variation in profile A ARM processor, like the 32-bit processor and the 64-bit processor. So the difference between 32-bit and 64-bit is the usages of memory addresses, the size of memory addresses used by a process. So in a 32-bit processor, a process can use memory addresses up to 2 to the power 32, whereas in a 64-bit processor, a process can use memory addresses up to 2 to the power 64. So from the ARM version 8 profile A ARM processors of the ARM architecture, the ARM started supporting 64-bit addresses and memory operations. Any processor of the ARM version 8 will run 64-bit processes. Prior to ARM version 8, or we can say version 7 or prior to that, were all of 32-bit, which all the IoT devices in today's world uses. So in 32-bit also there are certain versions we might need to notice about. There are two types of versions, ARM legacy version and ARM hard float version. So the instruction sets in the ARM legacy version is way more different than the instruction sets in the ARM hard float version. So learning about ARM legacy version is of no use because it is very old. Learning about the ARM hard float instruction set, ARM hard float assembly will benefit a lot because all of the IoT devices uses ARM version 7 of processors which have ARM hard float assembly. So a program in ARM legacy is not able to run in ARM hard float version of processor. It is quite simple because of the distinction of the instruction set of both of these processors. You can just understand the concept behind it, like using a cycle tire in a car. You can't use instructions of ARM version 4 or prior version of processor in ARM version 7 of processor. So it is a same concept like using a cycle tire in a car. There are some modes in ARM 32-bit assembly which you will get to know. Those are ARM mode and thumb mode. So in ARM mode, a process can use 32-bit memory addresses, and in thumb mode, a process can use 16 bits of memory addresses. The usages of thumb mode and ARM mode is pretty simple. Just lowering the size of your program, maintaining a decent amount of speed in the execution, and many more. We can shift a program execution from ARM to thumb and thumb to ARM in a single program. We will see how to do that in the module 2. The ideology to just shift the execution from ARM to thumb and thumb to ARM is to make the program pretty small and fast, because using 16 bits of memory addresses will require half the time or more than half the time than a process may take in a 32-bit mode. Moving on to the end of the video, if you have any question related to this video, you can just ask in the comment section. Show some support to the content, drop some likes and subscribe. If you want to follow me on GitHub and Twitter, you can just locate to the slides PDF given in the description and click on that link. That's all for this video. Thank you.